Introduction to the periodic table. The periodic table is one of the most powerful tools in chemistry, and on the MCAT, it's more than a chart of elements. It's a roadmap for predicting reactivity, bonding, and even biological relevance. Whether it's knowing why sodium reacts explosively with water or why oxygen drives metabolism, the MCAT expects you to understand how the table's organization connects to chemical behavior. Let's break it down. Organization of the table. The periodic table is arranged by atomic number, electron configuration, and chemical properties. Elements line up in periods, horizontal rows, and groups, vertical columns. This simple layout encodes a lot of chemistry. Periods and blocks. Each period corresponds to an energy level, or electron shell. The table is divided into blocks, S, P, D, and F, based on which orbitals are being filled. On the MCAT, this helps you quickly identify electron configurations. Groups and families. Groups share chemical properties because elements in the same column have the same number of valence electrons. Group number equals valence electron count. That's the shortcut to predicting how atoms bond or react. Valence electrons. Valence electrons drive reactivity. They're the outermost electrons that participate in bonding. For example, elements with one valence electron tend to lose it, while those with 7 tend to gain one. Main group elements. Groups 1, 2, and 13 through 18 are the main group. Their valence patterns are predictable, which is why the MCAT often uses them in reaction or bonding questions. Transition metals. Groups 3 through 12 are the transition metals. They can have multiple oxidation states and often form colored compounds. A classic MCAT point, iron and hemoglobin switches between oxidation states to bind oxygen. Alkali metals, Group 1. Alkali metals have a single valence electron. They're soft, silvery, and extremely reactive, especially with water. Sodium and potassium are biologically essential ions, showing up in nerve signaling and fluid balance. Alkaline earth metals, Group 2. These have 2 valence electrons. They're reactive but less so than alkali metals. Magnesium and calcium are big players in biology, from ATP stabilization to bone structure. Halogens, Group 17. Halogens have 7 valence electrons. They're highly reactive nonmetals and exist as diatomic molecules, like chlorine or bromine. On the MCAT, think halide ions forming salts, like sodium chloride. Noble gases, Group 18. With full valence shells, noble gases are stable, unreactive, and exist as monatomic gases. On the MCAT, they're often the inert comparison group in experiments. The periodic table isn't just about memorizing positions, it's about predicting patterns. For the MCAT, always connect an element's position to its valence electrons, reactivity, and role in biological or chemical systems. That's where the exam pulls questions from. With that said, here are just a few of our student success stories. Students who mastered these concepts, boosted their scores, and got into medical school. If you're studying for the MCAT, click the link below to get started with your own prep. We help students reach a 515 plus on the MCAT, and we'd love to do the same for you. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.